Welcome back to Bites of Pi. Today we're going to talk about classes in depth. We're going to get to that next level. For the first part of advanced classes, we'll be talking about primitives and object variables, references, the null in this reference, and testing for equality. For this first section, we're going to talk about references, variable references. We're going to begin by having a refresher on primitives and objects, variables, how they work. We'll talk about assignments of variables, how we assign one variable to another, and then passing by value in functions. So to understand how variables work, we have to remember the differences between primitives and objects. So here's a couple examples. Here's an integer primitive. So I'm setting the value, the literal 21 value into this object. So I've carved off a chunk of memory in space, maybe like 32 bits, and set the value to that location. So A sets the actual value of the primitive. Booleans are very similar. Essentially, it's just 1 byte. It's either 0 for false or 1 for true. So we show that here with false or true instead of 1 and 0, but under the hood, that's really what's doing. It's just flipping either a byte on or off. But that value is so small, the values are so small, they can be stored in this location. So that's what primitives for. You store the values in the location given by the variable. Now objects, they don't have enough room to store all the pieces of the object in just like a 32 bit area. So what we do is when we create like a string, I create that chunk of memory, I carve out a chunk of memory in space. Each of these characters has its own memory location, and the string object points to those each of those locations. It's given an address, address 141, and the variable stores the address of where that string object is in memory. Okay, so it's essentially got a pointer to that location. So that's what's stored in the variable, the address to the object. And this works also for custom objects. So here, if I created a custom object car, I'll create that object in memory, and I have the address, let's say address 162, and in the variable I'm storing the address to where that car is located in space. So this is key to remember. Variables, primitive variables store the value actually in the memory location, and for objects they store the address. So when I want to assign one variable to another, I'm copying what's the value of the variable. So when I copy an integer, so I'm going to create an integer here. I have the literal 21 in I first, and then I have the value 32 in I second. When I copy one variable to the next, I'm copying the value in that variable. So here I'm going to set first equal to second, and you notice that I no longer have 21, I now have 32 because I copied the value over. Now, when I create a car object, I'm not copying the object. I'm copying what's in the value, which is the address. So here I've got a red car at address 152. So that's what's stored in the variable car first is the address 152. I create another object, car second, at 162. And I copy the value in here is the address location of where that second car is. When I set one car to this other car, I'm not creating a new object. Notice I didn't create a new orange car. I copied the value. So I'm copying the value over, which is the address. So now both car first and car second are pointing to the same object. I didn't create a new orange car. I have the same orange car, but the address location is pointing to the same object in memory. And this is key to remember when we start messing around with them in methods. So we've talked about methods where program execution starts in one method and then jumps over to another method. When I pass in values, I'm creating new variables, and I'm copying, just like an assignment, just like we had in that previous slide. I'm just like an equal sign, I'm copying the value over. So let's take a look at that. I've got an integer primitive value of 20, and I've got a car object with an address of 152. Now if I called a function called print miles, I'm going to pass it in the primitive and the object. So I'm going to create a copy of those values. So here I've got the values are assigned. We create two new variables, in miles and in car, and the values of those are copied from what I passed in. So the value of 20 gets copied over to in miles. The value of car is copied over to in car. Note I didn't create a new car, I just copied the value over. So both car and in car are pointing to the same car. Now, what happens if I change the value inside the method? Because I passed a copy to the method, if you modify the primitive or change the object's reference, it won't change the original value. However, if you pass a reference to an object and then you change the object itself, the object's changes will remain when you return from that method. So let's start with that first part. Here I've got the main function, and I'm going to create a variable, miles equals 20, and then a car. I'm going to create a red car. Now I'm going to call change values. So when I call change values, I'm going to pass in the values, and that created two new variables, an in miles and in car, and it copied the values over. Okay? So now I've got two sets of variables, one outside the function over here in the main function and one inside the function. So when I try and do something with in miles, I'm going to change the value here. Notice it changed just in miles. It changed this variable in here. It did not change miles out here. Miles is still 20. I'm going to change the location. I'm going to create a new car and change the location. Note, I created a new car. I called the keyword new and created a new object. I didn't change the original object. I created a new object. So I'm going to print out the variables here. So when I print that out here, notice it's the new variables 75 and the orange car at location 162. I printed that out. Now, once I'm done with that, when I return, these two variables disappear because I've reached the end of the function. In miles and in car are no longer exist, so they disappear. Now, I'm printing out the original values. Notice, because I've printed them out, I've lost the link to the orange car. Car is still pointing at the red car, and miles still is 20. So when I output that, I'm outputting 20 and red car because they never changed. Remember, so I'm copying the values into the method. Now, here's where it gets kind of strange. Now, if I change the object itself, it will actually stay when I leave the function. So in the previous one, I created a new orange car. Here, I'm going to create a red car and set car equal to that value. I'm going to call change car values and pass in the reference to that red car. So they're both variables are pointing to the same red car at address 152. Now, I'm going to call that car's function set color. So I've just changed that object's color to orange. Still pointing at the same value, but notice they're both pointing to that same object. So I'm going to print out inside the function orange car. When I leave the function, in car disappears, but car is still pointing to that same object in memory, and I've changed that value. So when I print car out here, it's also printing an orange car. It didn't print out the red car, it printed out an orange car. This section will talk about references. Null reference, these are keywords in Java, null reference and this reference. So object variables that don't point to an object are null. If you don't initialize them, they are null by default, and you can also explicitly set them to null. So I'm going to create a car. Notice I didn't use the keyword new car. I'm just creating a variable, my car. So by default, since I haven't created the object in memory, the address is null. I don't have anywhere to point to, so we set that to null. Here I'm going to create a new red car, and I actually created a new red car in the address location. The value of red car is the address of where that object is in space. I'm going to set that car to null. So I've lost the pointer reference to I've orphaned this out. It has no variables pointing to it now, and I've set this to null. So I can either have it implicitly set to null or explicitly. Now notice a lot of people have had issues with null pointer exception, and this is why. If you didn't specify a new car, you didn't say the keyword new, you didn't create a new string or whatever, you'll probably get a null pointer exception. And here's an example of what that looks like. So if I create a variable test called null, I didn't create a string, so it doesn't exist. Now because it's a variable and it doesn't exist, I can still call functions for that object. But because the object doesn't exist, your compiler will complain. Now you won't notice right away, but when you actually try and run your program, it'll get to this point, think that there's an object there, try and call a function, and because there is no object, you'll get a null pointer exception, and it'll say this line, hey, test, there's no object in test, I can't call a function for an object that doesn't exist. Now, this reference, if you need to refer to a variable inside the function, you can use this reference. And this is really cool because editors like JGrasp and Eclipse kind of give you hints as far as the color of the variable. Now, notice car has a member attribute called color. So they've got a variable called color, but its function also has an input value of color. Now, this gets confusing if I was to say I want to set color equal to color, because they're the same, they're named the same. So if I was to do something like this, so if I was to say color equals color, notice the color of the actual color of the variable is they're both pink. Because I don't know, this function doesn't know the difference between, it doesn't know which one you're referring to. Am I setting this equal to that or that equal to this? When I refer to color, by default, both of these variables point to this input variable. So when you say this, your compiler won't complain and it'll work, but it won't do what you think it does because they're both pointing to the same input variable. You're doing nothing. So what you want to do is use the keyword this. And notice I pulled these values from Eclipse. Notice how the color of the variable is different. When I use the keyword this, it says I'm pointing to this car object, this current car object, and I want to use the member attribute color from this car object. So when I use the keyword this, I'm referring to this attribute. This, because I didn't specify this here, is pointing to the default input variable here. So it's clear when you use the keyword this that you're setting this attribute equal to the input value coming into the function. Lastly, we'll talk about testing for equality. Now, we're familiar with testing primitives with the double equal sign. So here I've got two variables, a and b, and I'm comparing the values in those variables. 21 equals 21, so this will work. This will do what we think it does. A equals b, int matches. However, we can also, because they're variables, I can also use double equals on objects. However, it won't do what you think it does. So here I have created two new red cars. They're two different objects. So I have object 152. I've created a red car at address 152, and I've created another red car at address 162. When I use the double equals sign, I'm comparing the address values. It'll say, does 152 equal 162? And of course it doesn't, so this will not print out because they don't match. Now, you may have intended, when you created your car object, to compare the colors. You say, well, I want them to equal because they're both red cars, right? Well, that's where we get into the method equals. So for objects like string or other custom objects, you want to use the function equals. And here I really intended to say, when I compare the two, I want to say, do they have the same color car? Are they the same color car? So in the car class, I've defined this function Boolean equals. I'm going to pass in another car. So when I say this color equals the other color, so if I passed in a an orange car and this is a red car, I'll say red equals orange. No, that will return false. But if I returned in a red car and I said red equals red, I want this to return true. So that's why when I do the comparison of car A and car B, even though they're the red, I don't use the double equal sign because that just compares address values. I want to call this function which will compare the colors. So this will work. This will print out because they are both the same color. Even though they're not the same object, I want to say they're quote-unquote equals because they have the same color. This concludes going in depth with classes. Thanks for watching.